Hi, hello everyone. Welcome back to my YouTube channel Spotify Learn. Today I'm here with the video of last video I have uploaded ML only questions. If you have not watched that video, please do watch so that you will get what are the theory questions that you have to focus. In this video, I'll be just explaining all the numericals that is required of all the modules, all the 5 modules I'll be explaining. If you're watching my channel without subscribing, make sure to subscribe and then watch the video. Let's start without further wasting time. Okay. See, first question is about the binning techniques. Binning techniques is they have given a certain data set. As they have given 9 elements, it is there here you can see. So you can divide it as 3. Okay, 3 3 3, so it will become equal size of 3. Okay, now you will divide it and you will write it in the first step. Next you can do it in the method of by means. Okay, it will be saying as smoothing by means. Okay, first step is smoothing by means means you have to find the average. That means 12, 14 and 19, if you add you will get it as 45. 45 divided by 3, because 3 elements are there, you will get it as 15. So you have to replace all the elements by 15. Again the same method here also. Again here you will get 24 and 30.3. So you have to replace all the 3 elements by the means. Next method would be by median. Okay, now in the place of median means you have to find it. Okay, and median, it's also the middle value you will be replacing in the second method. And this is about the boundaries. Okay, by this you can do in the second step by median. Okay, this is what I said was about the median. Next is third step, you can do by boundary. Boundary means you have to see the bin value is replaced by the closest bin boundary. If min and max values are there, that is the boundary that you can say. Okay, in 12, 14 and 19, this is the minimum value and this is the maximum value. As you can see, this 14 and 19 difference is 5, but 14 and here the difference is 2. So you will replace it by 12 12 and the maximum value will be same as it is because you are not replacing that value. Okay, now next you can see here again 22, here the difference is 2, here the difference is 4. Again you will replace 22 and 22 here also. You will keep the maximum element as it is. And here you can see 28, 31 and 32. Here the difference is 1, here the difference is 2. So you will replace the maximum element and you will keep the minimum as it is. This was all about the binning techniques. Next we will go on to the next concept, that is about the min-max procedure. This is very easy if you know one formula. See, the minimum of the list V is 88 and the maximum is 94. Here you can see new min and new max are 0 and 1. You have to assume that new min is 0, max is 1. Okay, that you have to consider. And the formula will be as it is. Minimum minus, see, in the theory part it's been explained. Now what you have to do is, see what is the element that is given, that is minimum minus minimum minus, see what are the elements that are there. Okay, see here the varies, it is the V set. Okay, V minus minimum divided by max minus minimum into new max of minus min, that is this is new. Okay, this what you consider as 1 minus 0, this will be same for all. Okay, next plus 0. Okay, plus new min. Okay, that you will be adding. Here V means you have to do it for all the individual elements of this. This you will be replacing, that is 88 minus 88 divided by 94 minus 88 into 1 minus 0 plus 0. You will be getting it as what? 0. Again, next you will be replacing this with 90. Again, what you will be getting? 0.33. Again you will be doing, and see what is the difference you find here is, it is observed that it started from 0 and the last answer is 1. So the answer is between 0 to 1. That is how you write the conclusion here. Okay, that is about the min-max finding. Next is about the z-score. This is also one of the repeated question. See, first they have given 10, 20 and 30. You have to convert it into z-score. Okay, what you will be using here is, the mean and standard deviation value is 20 and 10, because you will find the average and standard deviation using the formula. You will be getting 20 and 10. Okay, here 10, 20, 30 if you add, you will be getting as 60 divided by 3 will be 20 is the average. Again you will be finding the standard deviation, you will get it as 10. Okay, now you have to find it for each element 10, 20, 30. That means you will be calculating mu minus, that is mean minus standard deviation divided by this is mu, that is the value of v that is given, divided by mu. Okay, that will be here sigma, here it is mu. Okay, that is v value, that is 10 and 20 and 30, it will be varying, minus what is the mean that you have, divided by standard deviation. That is how you find out this z score. It will be from -1 to 1. Okay, -1, 0 and 1 it will be. That is in z score. In min max it will be from 0 to 1, between those numbers. Next IQR, that is interquartile range. That is see, they have given a patient list, age list. Find the IQR, interquartile range you should find out. See, first the fifth position is the 1, 2, 3, 4, 5. Okay, this is the median. Here also 1, 2, 3, 4 elements are there. So it is the middlemost element which you consider it as the median. The first quartile of the median score is the left side, and the right is the above, that is above, that is greater than that. And if you find out the median of the second and third values, this see second and third values median is, if you take out the average you will get it as 16.5. And again the right side median, again for 28 and 31 if you take out, you will get it as 29.5. Again you take out the difference between 16.5 and 29.5, you will get it as 13. And the formula is, this is just you find out the interquartile range, but you want the semi-quartile range. Okay, so in order to find that, you will be dividing it by 2. That is 13 divided by 2 will give you 6.5. That is the answer here. Okay. Next is about the 5-point summary. 5-point summary for the given list they have given. See, first is minimum is 2 and the maximum is 13. Minimum is 2, maximum is 13. So Q1, Q2, Q3 are 3, 8, 11. You have to arrange it in the order. Okay. That means you, after you arrange, it will be minimum, Q1, median, Q3 and maximum. See, middlemost element, this you will consider it as Q1 element, Q2 element. This will be the minimum element, this will be the maximum element. And you will plot as it is. See, first what you are doing here is, first you will plot for the first, and you will make a box for what is the element it is, and next what is the marks scored, you will be plotting it according to that. Okay. Next is finding the kurtosis for the given value. They have given a set. First you find out the mean for the same, as it is 10 elements, you divide it by 10, you will get it as 9. And the formula you have to remember here is summation of x minus x power 4 divided by n divided by sigma. That is the standard deviation, and you will get the value. Here I have given the x minus whole power 4 and x minus x whole power 4 formula. I have given the calculation table also. You will get it as 11910 if you do this, and divided by 10 will give you 1191. The kurtosis value is the standard deviation divided by here this, and you will get the value as 372.58. This was all about the module 1 video. Now let's continue with the module 2 also. First here is you have to find out the covariance. See, first covariance of x is equals to 1, 2, 3, 4, 5, and here they have given value of y also. See, first you have to find out the mean, that is mean for x and mean for y. You will get it as 3 and 11, and what you have to do is take the individual element here and subtract with x mean and subtract with y mean, and again you have to take this value and this value, do with x and do with y. That is how you do with all the corresponding elements. You take 2 and do with 1, and take 4 and do with 11, and take 3 and do with 3 again, and you have to do, here it should be 3 here, not 30. Okay, then again you have to take 9 and do with 11, 4 with 3 and 16 with 11, 5 with 3 and 25 with 11. Again you have to do the same, and you will get the answer that you will be taking it as the covariance. The covariance value is 12. Okay. Next we will find out the correlation coefficient. Again you will find out the mean values, that is 3 and 11 for the same data set. What you will do here is, See, covariance, you find out that 12, right? That you know, that you have to find. If they give the question, you cannot say that we have found out. You have to find the covariance that divided by, see, what is the value of 1.41 and 8.646 is standard deviation for this and standard deviation for this. You can find it out, then you will get it as 0.984. See, first, what you have to do is, consider the data set 1, 2, 3, 4 and 5. For this, find out the standard deviation. See, when you have to find it out, first find out the mean. That is 5, 4, 3, 2, 1. If you add, you will get it as 5, 4, 10 and 15. 15 divided by 5. You will get it as what? 3. Okay, that is the formula you will get. Okay, next, if you want to find out the standard deviation, what you will be using here is, that is, if you have the sum of square, that is, see, you have the mean. In order to find out the standard deviation, you want the mean. So you remember the mean is what? 3. Okay, now for the given data set, we will find out the standard deviation. I'll be just explaining for 1. Okay, 1, 2, 3, 4 and 5. X value and x minus 3 because the mean value, and you will be doing it for 1, 2, 3, 4, 5 value. Okay, see, first for 1 value it will be 4, that is 1 minus 1. See, I'll be doing, see, for 1, 2, 3, 4 and 5 values, that is x value. Okay, it will be varying. X minus 3 if you do. 1 minus 3 is minus 2 and here it is minus 1, 0, 1 and 2. Again, what you have to do is this square you have to do, that is 4, 1, 0, 1, 4. Okay, now you have to add these. 4 plus 1 plus 1 plus 4, you will give you, that is 10. Okay, 10 divided by how many elements are there? 5. That is 2 you will be getting. What is this 2? Sigma square. Then what you want? Sigma, that is equal to root 4 is equal to 1.414. Again you will do for same y data set also. If you divide by the covariance divided by the standard deviation, you will be getting the correlation coefficient. Next is about the Gaussian elimination. This is also one of the easiest. See what they have given in this equation form. Just convert it into matrix 2, 4, 4, 3, 6 and 7. And you have to do the row operations or and make it to one identity matrix is the main idea here. See, first you will be dividing it by 2, that you will get it as 1, 2 and 3, 1, 2 and 3. Again you will be subtracting the row 2 minus 4r1 because you have to make this as 0 and here it became 0. Again the values changed here. Again you will be dividing it by minus 5 because minus 5 divided by minus 5 will be what? 1. Okay, so you made it as 1. Here also it became 1. So the row 2 operation is done. Row 3, what you have to do? Row 1 you have to do is, see, row 2 minus 2r1 you can do, right? 2 minus 2 will be giving you what? 0. Here you want 0 and here also it became 1. So the value of x1 is also 1, x2 is also 1. That is reduced. That is Gaussian elimination method. Next is LU decomposition of the given matrix. They have given a matrix, you have to find it out and you have to multiply it with first identity matrix and the given matrix. This is, you consider it as the initial matrix, and what you have to do here also, it is again the row elimination you have to do and you have to make it as, find out the value for each of the element. See, again you will be doing, here it is 1 0 and here it became 1 0 0, 1 0 0, here it became, okay, now the value became upper triangular, lower triangular matrix you have done. Okay, now you will find out the value. Here it is 1 to 4 and here it is row matrix, and now you will compare, that is lower triangular matrix is this, upper triangular matrix is this, so you will consider LU and that is how what the answer you wanted. Just you have to find out the row operations, that is you have to make it here lower triangular, here you should make the upper triangular. That's it. Next the question is you have to find out the, they have given population mean and population covariance. You have to apply the Z test. That was, we studied in module 1 was Z score. Here you have to do Z test. Okay, consider the elements as 1 2 3 4 5. Okay, now the mean will be 3 and the number of samples is 5. You have to substitute, that is x minus mu divided by sigma divided by root n, that is number, you will be getting it as minus 10.06, and the critical value at 0.05, as it is rejecting, it will be null hypothesis. H naught is rejected because it is the negative value and it is lesser value. Okay, next is about the chi-square, that is having 50 girls and 50 boys. They have given a data set. See, first boys, girls and total number of students they have given. First, if you want the, you have to see the data set here. Here see, 50 boys are there, total are 60, total number of students are 100. This is total boys. Okay, total boys, and that next is not registered is 50 and total is 40 divided by 100. Again you will be getting the data set you will be doing for both boys and girls. Now what you will do here is sigma of observed minus expected divided by expected, this whole square you have to do. See, first what is observed? What is observed here is 35. What is expected is 30. That you will be subtracting. Divided by expected is what? 30. Okay. Next again 15 minus 20 divided by 20. Again next is 25 minus 30 divided by 30. Again next is 25 minus 20 divided by 20. You will be getting it as 4.166. Okay, that is the degree of freedom. Okay, for degree of freedom, number of categories is 1. Okay, that is 2 minus 1, number of boys and girls. So if you want the number of categories, to n minus 1, so n is 2, 2 minus 1 is 1. Okay, now the value, statistic value is p value. This you have to see from the table, 0.0412, that is less than value, so the result is significant. Okay, and the hypothesis is accepted. Next you can say the PCA. This is also one of the important concept. 2617 they have given. See, 2 plus 1 divided by 2, that is 2 plus 1 divided by 2, you do 6 plus 7 divided by 2 because 2 elements are there. You will find out the mean first. Next what you have to do is subtract from the adjusted data, that is here you can see what is the mean you got, you have to subtract from each of the element. You will get it as 0.5 minus 0.5 minus 0.5 and 0.5. Okay, now you have to see 0.5 and minus 0.5 is there, right? You have to transform this. Again you have to make rows as columns, that is 0.5 and minus 0.5. Again you have to multiply this again. Okay, then next again here also you got minus 0.5, this take it to column and make it as that, and you will get the value of matrix. Next what you have to do is consider a is equal to minus 1 by root 2, 1 by root 2, 1 by root 2 and 1 by root 2, because you will find out the normalization you will be applying in the next step. That is, you will be having minus 1, 1, 1 and 1. You will be converted into the matrix, and the transpose matrix will be also the same, that is minus 1, 1, 1, 1. So you will be applying the normalization. You will get the vector as, that is root of 1 plus 1 will be what? Root 2. That is root 2. Again 1 divided by root 2 you will be applying. Here it is minus, here all it is plus. That's it. You will be dividing it. See, 1 divided by root of 1 plus 1, it is 1 by root 2. That is the normalization. And next is A into A transpose. A is this matrix and A transpose is also the same matrix. So you will be getting the identity matrix. If you multiply any same matrix, you will be getting the identity matrix. Okay. Next the formula you have to remember is A into X minus M. Again you will be applying A into X minus M, and you will be having the matrix which we found out here. Here C matrix, you will be multiplying and you will be getting this matrix. And what you have to do is you have to verify that what it is correct or not. You will be checking A, that is A transpose and A, it is same only. So you will be checking A transpose matrix into the matrix which you got here plus the mean which you have got. You will be getting the same matrix 2617, so that it is correct. That is done for PCA. Next we will be doing for SVD, that is what they have given, 1, 4 and 2, 9 they have given. What you will be doing, 1, 4, 2, 9, you will be converting the columns, rows as columns, and you will be exchanging, that is transpose you will be doing, and you will be multiplying, you will get the one matrix. Okay, now the eigenvalue and eigenvector for the can be calculated to get you, that is eigenvalue and eigenvector for the matrix will be as 0.0098 and 101.9902, and you will be getting the same way. Again you will be splitting it as this, and the eigenvalue and eigenvector, and you will be normalizing, that is you take the root and you will be getting this value, and again you will be having u value, a into a transpose you will do, again v1 v2 you will be getting, again you will be having the last, that is v1 v2, this only, and you will be multiplying this both matrix and you will get one matrix that is said to be the single, yeah, this you will be removing the root means you will be getting some value, so this is the vector decomposition matrix. Okay, next is, this is one of the important concept, this is one of the repeated find us algorithm. They have given a data set, they have given first what you have to do in step 1, you have to, what you are doing here, it is most specific hypothesis, there are 6 attributes, so for each attribute you will give it as null. Okay, 1 2 3 4 5 6, because here it is 1 2 3 4 5 6, here it is not considered because they have given job offer as yes or no. Okay, they have given job offer, this you have to not consider, because this you will be seeing whether the answer is correct, that is whether this student have got the job offer or not, just you are verifying by this column. Next is about the generalize the initial hypothesis for the first positive instance. That is, if it is a positive instance means it will be generalizing. That is, first it is the job offer is yes. So you consider it as a positive instance. Okay. Now what you will be replacing, the iteration will be this instance 1 and the hypothesis will be replaced by the same elements. Okay. If it is a positive instance. Now again it is the positive instance next also, because the job offer is yes here also in the second instance. Again what you will be replacing this here, and yes, you should compare this I2 with the H. Okay, I2 it is same, your yes replace with the same, yes yes you replace with yes, here it is excellent, here it is good, so you replace with question mark. Question mark means it can take either excellent or good, both the values it can take. Okay, next here it is good 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 only, fast 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 only, yes 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 only. Next see, you have negative instance. Negative instance mean you should not change if the value changes. Okay, it is a ignore. Okay, like what you have to do here is, see, you have to compare I3 and H again. Here it is different values, right? So you have to consider the positive value only. See, here it is greater than or equal to 8. Here it is greater than or equal to 9. This is positive instance. This is negative instance, right? So you have to consider the positive instance 1 only. So you'll be replacing with greater than or equal to 9 only. Next here it is yes and no. You consider positive. So you replace with yes. And good, and here it is also good. So you will be what? Sorry, here it is question mark, right? Not this. You should do with hypothesis. Next here it is question mark. Question mark you will be replacing with question mark only. Next here it is what? Good and good. So good only. Fast and fast. Fast only. Here it is no, but here it is yes in positive. So you will be replacing it with positive yes only. Okay. Next again it is positive instance in the fourth instance. So you'll be comparing with previous. See, same value greater than 9, yes 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 only, question mark good good good, and here it is fast, here it is slow. So fast also it can take, either slow also it can take, so you will replace with this. If it is different value, replace it with question mark, same value replace that value only, replace that only. Okay, next here it is yes and here it is no, it should take both the values, so you should replace with question mark. So the find us final hypothesis is greater than or equal to 9, yes, question mark, good, question mark, question mark. This is how the find us algorithm works. Okay, next is about the candidate algorithm. We will be discussing, it is also same, but a single change will happen. First you will be taking the hypothesis as question mark. Okay, it can take any values, then you will be making it as, it will be generalized, it will be G to S, that is general to specific, but here it is specific to general. Okay, in find us. Next is you will be taking question mark, and yes, you will be updating it as null, and first instance you will be taking greater than or equal to 9, what they have given, it is a positive instance. Okay, now what you will be replacing S1, it is the same value, and G1 will be question mark as it is, because there is no change, it is a positive instance. And if negative instance come, the G will be changing. Okay, Now you can see here again it is positive instance s2. Again you will be comparing with previous, that is greater than 9, greater than 9, yes, greater than 9, yes, it is good and excellent, it is there, you will be replacing with question mark. Good, good, yes, fast, 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 yes, yes, yes. So you will be replacing with same. But here what G will be there, it is also same, that is question mark, because it is a positive instance. Next you will be going to iteration 2, that is you will be considering the instance 3. This is having the negative instance. Here the G value will be changing. What you have to see here is greater than or equal to 8 and greater than or equal to 9 here is okay. Now what you have to consider is about the positive instance. Here it is greater than 9, so you will be considering it as the same. Here it is yes and here it is no, so any value, question mark, question mark, so question mark, good and good. Sorry, here it is missed, okay. Yeah, see, this is nothing but they have given for only for this CGPA, and this is for yes. Okay, this is yes and no is there, so question mark, and next is good and good is there, so good, and fast and fast is there, so fast, and yes is there and no is there, you will consider the positive one, so it is yes. See, just to have to remember, if it is negative instance, the G will be changing. If it is positive instance, yes will be changing. Next again the positive instance, yes will be changing. Again yes, good, good is see here it is question mark, so here it is question mark, good, good, good only, fast, slow, question mark, any values, yes, no, yes, this question mark, any values it can take. Next is what you have to say here is it is inconsistent. Why it is inconsistent means because it exclude all the values, that is only it is including greater than 9, yes, and here also yes, it is excluding all the instance hypothesis with positive value, so it became the inconsistent value. Because you can see in the above data set, which they have given here, sorry, it is the same data set you have to consider. See, when they give for this yeah, I'll be erasing this. Yeah, they given here, here, and here it is positive instance, right? See, this all the criteria which they have given, it is failing, so it became the inconsistent. What now, what you have to do for inconsistent means you have to check the third hypothesis and remove that, so that the resulting G4 you will be getting. Okay, now what you will be doing, the third G3 you will be removing and you will be replacing this, and what is this here you replaced, and now you will be getting the final hypothesis is greater than 9, yes, question mark, question mark, question mark, question mark, this, and you will be considering this again, this, and here it will be good and here it will be good, here you will be taking the yes. That is about the candidate algorithm. You can do the tree also for this. This is all about the module 2. Next we will be discussing about the module 3 also. Next, this is about the, you have to check whether the test is pass or fail. Okay, now you have to do, what you will be applying here is, first you will be, yeah, using a discrete method you will be doing. Okay, first discrete method, and next you will be doing it with continuous. Okay, discrete and continuous, both the methods are there, so you will be applying that. First, in discrete, what you will be finding, Euclidean distance. Euclidean distance means subtracting the difference of distances within themselves. You are finding here the nearest neighbor, KNN you are applying. Now given data set here is, you will be taken, see here you will be taking, and first what you will be doing, given a test instance, they have given this. Okay, this will be given in question, that is 6.1, 40 and 5. You have to check for this instance, they will be saying, okay, whether the pass or fail, okay, for the classes. Now what you have to take here is, assign k is equals to 3, that is k nearest neighbor, so you will be applying the value of k as 3. Okay, now you will be saying it as, First you will be finding out the Euclidean distance, because see 9.2 and the given test instance is what, 6.1 for this, and here it is 6.1, here it is 40, and here it is 5. Okay, you will be subtracting for all and you will be finding out the Euclidean distance. Next what you have to do is, see, first you have to take the instances, that is 4 which they have taken, that is according to the see, first sort the distance in ascending order and select the first 3 nearest training instance. See, first you will be having 45 and all, it will be lot there, it will be last 45, this 5 you consider, and you consider this, and you consider this. Okay, this is 30, it became large, it became large. So 2 5, 2 5 and 10, this is 2.02, this is 5.001, and here it is 10.05. okay, you consider this 3 values, that is having 5 6 and 7th instance. Okay, that you will be considering, and the result would be fail. Okay, the class would be fail as it has the smallest value, so the resultant, the answer would be printed as fail. Okay, because the class for the test instance is predicted as fail. Okay, majority voting. 4, 5 and 7. Okay, now it is fail, it is considered to be fail because the value is less, and the given test instance, for the given test instance is it, yes. Now you will be using weighted KNN. Again you will be finding out the what Euclidean distance. Now again the test instance will be given as 7.6, 60 and 8. Again you will be considering it as, see, here it is 2 fail and 1 pass. So what you will be doing here, it is weighted KNN you will be applying again, because the only one class should be predicted, right? So you will be considering this 3 instance again for what you got. Again you will be applying the Euclidean distance, what you will be there, you will be reversing it. That means 1 divided by 15, that you will be doing 10 divided by 1 divided by 10 point, 1 divided by 12 point. Again you will be getting some of the inverse distance here, and what you will be doing, inverse distance divided by sum of them. Okay, that means you will be sum up them. Okay, next you will be getting, here it is fail, fail, pass. Again next the fail percentage is what, 0.27 and 0.38, you will be adding 0.65, that is 65% you got fail. So the majority is, this is if you have 35%, right, if you remain 100 minus 65, so this is pass, so the majority is fail, so you will be considering it as fail only. Next you have to do here is linear regression. This is also one of the repeated concepts. See, they have given a data set. Here you consider it as 1 2 3 4 5 and compute the table 1 2 3 4 5, and they have given the value. Here you do the square of this and you multiply this xi and yi, and now you sum up this, that is this sum, this sum, this sum and this sum, and you take the average and you will be getting the values, and you have to substitute, that's it. Okay, now what is the sum of this? Okay, this you will be replacing here, 3 into this divided by 11 minus this square, and you will be getting the answer. You will be just plotting it in a graph. Okay, that you will be getting, and when you get a graph you will be applying this formula, you know, I guess, a0 in plus a1 into x. Okay, the value will be 0.54, 0.66 and this 0.54, 0.66, that is a0 and a1 value, and you will be replacing 8.46. you got, that is the value that is needed. Next is you have to apply whether the job offer is yes or not, and you have to find out the entropy and the information gain. First what you will be doing here, it is in the first step, see, first you will be seeing the data set, and only 1 2 3 4 is there, so you'll be having 4, right? When you find out the entropy, that is 7 by 10, that is how many job offer is yes and how many job offer is no. That is job offer yes, idu job offer no. Okay, 3 by 10, and you will be doing log 2. For that you will be getting one particular value. Now what you have to do is you have to find out the entropy info and information gain for the attribute. Okay, now what you will be doing, you will be taking the for CGPA individual, next you will be taking for the interactiveness. That is how you will be calculating for individual values, that is greater than 8, 9 and less than 8 is the 3 possible CGPAs in the given whole data set of 10 elements, and how many are yes, how many are no, you will be saying, and See, here it is job offer is no, so here it is became 0, here it is 0, and here it is 0. Again, the information gain will be, that is 0.8807, that is the value here you found out. Here 8807, that is entropy info for job offer, and minus 0.3243, that is you found out here it is entropy info, and we'll be calculating the same way for interactiveness, practical knowledge, communication skills, and last what you'll be doing is a decision tree. What you'll be applying here is, for CGPA, if it is greater than 9, it is what? For job offer yes and job offer no. If this is very good, practical knowledge good and average, job offer yes or no, that you will be calculating in a decision tree. This was all about the module 3 numericals. I hope you have understood. If you have any doubts, please do let me know in the comment box. I'll be saying. Yeah, now next question is about the perceptron. Okay, they have given a, consider a perceptron to a boolean function, and using AND function you should find out. They have given a weights, that is 0.3, 0.2, and a learning state alpha, and a bias they have given. First you will be considering it as a using AND function, right? 0 or 1 and 1 will be the output, and weight 1, weight 2, and you will be considering the bias, and the step function will be there. You will write the AND table first. Okay, this is one of the easiest. AND truth table, 0 and 0 will be 0, 0 and 1 0, 0 and 1 and 0 is 1, 1 and 1 idre matra illi output 1 agutte, that is in the AND table. Okay, that is you have to remember. And next what you will be using in this, epoch will be there. Okay, now you will be considering some of the epoch function, and you will be applying. Okay, see, first you will be writing here it is the AND table, and it is the AND table output. So that is the desired output. Okay, now what you will be getting, see, if you do step off, what you will be doing, step off, see 0, that is 0 into 0.3. What is the weights they have given? 0.3 and minus 0.2, right? That you will be multiplying with 0 and 0.3, 0 and 0.2, minus bias, that is bias they have given as 0.4, right? That you will be multiplying with the whole. You will be getting answer it as 0. Here you see 0 this and 1 here. Just you will be multiplying with the weights they have given and subtract by the bias. So you will be getting it as 0 0. See, what is error 0? I'll be explaining. If it is 0 desired and 0 what you got, that is expected, estimated, you will be writing it as 0. Here it is 0 and here it is 0. Yes, correct. Here it is 0, here it is 0, 0, correct. Here it is 1, but the estimated we got it as 0. So it is changed. So you will be writing the value as 1. It is changed, right? Next, again the weights will be keeping as it is, but the weights here it is changed. So now what you will be again finding out, delta W1, that is change in the value, that will be having alpha, that is the alpha learning rate that they have given, into error of t into x1. Again for x2 also you will be calculating error rate, what they have given, 0.2 into 1, that is 1 is nothing but the error of t, that is 1 value, and next x1 value here it is 1 again. Okay, now you will be getting it as 0.2. Next here it is 0.0. Okay, next again you will be calculating for epoch 2, and next you will be again doing until there is no change. Okay, epochs you will be repeating just the same steps. If you have the same error, this you will be keeping as it is. If you have the value as, see, here it is 0, here it is 1, but the minus 1 value, because there was 1 and 0, so you made it as 1. Here it is 0 and 1, you will make it at minus 1. See, 1 and 1 is there, 1 and 0, so you made it as 1. Okay, that is how you have to remember, and you have to do until there is no change. Next is about this naive Bayes. This is also very similar to the question we did in the previous third module. You will be just calculating the frequency matrix and the prior probability. Frequency matrix is nothing but how many number of offers you have. For job offer yes and job offer no, and you will be considering likelihood probability is for, see, 3 is there out of how many, 7. Okay, 4 is there, how many out of 7, and 0 is there, how many out of 7. 1 by 3 is 0 by 3 and 2 by 3. That is, first if you calculate this frequency matrix, you can easily write this likelihood probability matrix. I'll just explain for interactivity. See, interactivity, just how you have to see in the data set is, see, interactiveness is yes or no. Okay, how many yes are there? 1 2 3 1 2 3 4 and 5 are there. See, interactiveness, total yes is 5. Okay, next, interactiveness no is how many? 1 2 3 1 2 3 4. Okay, 4. Sorry, what I am trying to say is, see, you have to check interactiveness, job offer yes, interactiveness yes, job offer yes, interactiveness yes, job offer yes, interactiveness job offer yes is here and here it is. So it became 1 2 3 4 and 5, that is 7 out of 7, it is 5. Okay, next is interactiveness yes sir, job offer is no. Here you can see interactiveness, job offer no, and again where it is interactiveness yes and job offer is no. Yeah, here it is 1 only, right? You will be getting it as 1. And next is interactiveness is no, but job offer is yes. That is 1 and 2. That is it. 2 you will be considering. Again, you will be just checking, that is interactiveness and job offer yes, interactiveness no, job offer yes, interactiveness no, job offer no, interactiveness yes, job offer no. You will be calculating that, you will be getting some frequency, that is 5 2 and total is 7. Here it is 1 2 and total is 3. Okay, now what you will be doing while writing this likelihood probability matrix, probability of interactiveness is what? Yes, interactiveness is yes, and job offer is what? Yes here. So you will be writing 5 by 7 total, 5 by 7, 2 by 7, and here it is 1 by 3, 2 by 3. The same way you will be calculating and writing for all. Next, they will be giving a test instance, you have to check. Okay, they have given this test data. Okay, this is the test data. You have to say whether the job offer is yes or not, job offer is provided or not. First, for that, what you will be considering is, see, job offer is yes or test data. See, first you will be applying for job offer yes also you should find out, for job offer no also, which is greater you will be considering that value. See, I'll be explaining how. Sorry. Sorry, this was not I was explaining, I guess. Yeah, this I was explaining, right? See, when you come to the last step, what you have to do here is, see, first here you will be applying the base theorem. First, they have given CGPA is greater than or equal to 9. First, you have to consider CGPA greater than or equal to 9. How many job offer is yes? How many job offer is no? You have to consider those two. And again, you will take interactiveness yes, and how many job offer is yes and how many job offer is no. That many you will be considering. And here you can see when the job offer is yes and CGPA is greater than 9, you will be getting this values, that is 3 by 7. Total was 7 in that 3 and 5 by 7. Just you will be considering for all interactiveness, practical knowledge, and for all the communication skills and all, for interactiveness average what is there and all. And here it is 7 by 10 is nothing but 7 job offer is yes out of total 10 data set. 10 data set is given, in that total job offer is 7 yes. Okay, that you will be adding it here in last. So you will be getting 0.0175. Here you will be getting for no, that is CGPA greater than 9 or equal to 9, but the job offer is no is how many? Total is 3, but in that 1 it is there. And next is a 1 by 3, 1 by 3 and 2 by 3. In this total job given data set is 10. In that 7 is job offer yes, means 3 is what? Job offer no. So you'll be multiplying that, you got this value. But the value which is greater here is 0.01. Okay, 0.01 is greater than 0.00. Okay, so you'll be considering it as job offer yes. That's all for this. Next, again it is for continuous attribute also you have to do the same method. Again just it changes in the last step that you will be using a map, that is maximum a posteriori. You can see this. Okay. Next, the last module is module 5, which is also easiest. Again, just you have to consider the single linkage. Single linkage means first you will be using a table, that is priority matrix, proximity matrix, that is 0, 1, 2, 3, 4. You will be writing it rows and in columns, both the side, and you will be finding out the Euclidean distance between them. Okay, that is Euclidean distance means they have given, right, 1 minus 4 whole square, 2 minus 8, and again 5 minus 10, 12 minus 18, 14 minus. Again you will be considering the minimum value here, and you will be finding out the, you will be considering this minimum value, and you will be replacing, that is you will be combining the cluster of 1 and 2, because 1 and 2 is the cluster here, it is meeting the distance. So you will make it as 1 and 2. Again you will find out the distance between 1, 2, and again you will be replacing. That means you will be just finding out the distance, that's it. Okay, when you are finding out 0 and 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay, 0 to 0, this and all, it will be null. 0 to 1 when you are finding, that means you have to consider this both. Okay, 1 minus 4 whole square plus 2 minus 8 whole square. If you do this, value of 4.123 will be getting. The same way you have to consider the minimum value and combine the cluster and go. Next you will be getting the last iteration will be, see, everything will be combined, and this you can make it as question mark so that it takes any value. If you want, you can find out this value also, and you can plot a dendrogram. That is how you have to plot is 0, 0, you'll be considering up to 4, and here the distances are from up to 10 and 11, right? So you'll be considering it as in the units of 2, and you'll be plotting, that is 1 to 2 it considered, next 0 it added, next is 3, 4, and this 0, 1, 2 with 3, 4 it added. So that is how you will plot this dendrogram. That's it in the 5th module that we are having, the numericals, single linkage. That's all. And thank you for watching. If you want this same PDF, please do DM me. I have made all the question algorithms. Everything is being explained in this short one. And thank you for watching the video. Make sure to like, share, comment, and subscribe to my YouTube channel. And until next video, bye-bye. If you have any doubts, please do let me know in the comment box. Thank you for watching. Meet you in the next video. Bye-bye.